Picture a lion on the African savannah at noon. Every other mammal out there, wildebeest, zebra, hyena, has a coat of fur. Every single one. And then there's the thing jogging after the wildebeest on two legs, completely, almost aggressively naked, sweat running down bare skin. No coat, no pelt, just exposed. The wildebeest is going to overheat in maybe 40 minutes of hard running. The naked thing chasing it is not. That difference, that one wild, counterintuitive difference, reshaped the entire trajectory of human history, and the reason it happened is stranger than almost anyone expects. Here's the thing most people miss. Losing fur wasn't a random accident. It was a biological bet so drastic it changed what kind of creature a human even was. The question is why? Out of roughly 5,000 mammal species on Earth, only one of them made this particular trade. The oldest answer, and still the most satisfying one, comes from the savannah. Around 1.7 million years ago, in the grasslands of equatorial Africa, in a world that had no shade to offer, the forests earlier hominins had relied on were shrinking. And the creatures walking upright into that open heat had a problem every other savanna mammal had already solved. Most of them had evolved a biological cooling system called a carotid rete, a network of blood vessels that chills the blood before it reaches the brain. Humans never got that adaptation. The human brain is, and apparently always was, dangerously exposed to heat. Peter Wheeler, a researcher at Liverpool John Moores University, published a series of studies beginning in 1984 in the Journal of Human Evolution that mapped this problem precisely. Wheeler ran heat balance models on bipedal versus quadrupedal hominins and found that standing upright already reduced direct solar exposure by about a third compared to moving on all fours. But that alone wasn't enough. The bigger adaptation, the one that completed the circuit, was losing the fur. Wheeler's models showed that bare, sweat-dampened skin dissipates heat 2 to 3 times more efficiently than fur-covered skin. For a species with no built-in brain cooler, that wasn't a luxury, that was a survival prerequisite. But wait, here's the part nobody tells the story straight. Fur doesn't just trap heat. Fur also blocks heat from getting in. A woolly coat can actually insulate against external solar radiation, which is why desert camels keep their heavy coats in summer. So if fur works both ways, why would losing it help? The answer is sweating. Most mammals sweat a little, but rely on panting to cool down. Fast, but expensive in airway capacity. Humans evolved an extraordinary density of eccrine sweat glands across the entire body, up to 4 million of them, producing a whole-body evaporative cooling system unlike anything else in the primate family. And that system only works well on naked skin. Nina Jablonski, Evan Pugh University professor of anthropology at Pennsylvania State University, documented in her 2000 paper in the Journal of Human Evolution that evaporative cooling from eccrine sweat is significantly more efficient on bare skin than on fur. The moisture evaporates directly, rather than being wicked slowly through a hair layer. Lose the fur, gain the radiator. For a creature with no carotid rete and an increasingly large heat-generating brain, that trade was absolutely worth making. Now here's where the timeline gets interesting. For most of human history, scientists had almost no way to pin down when this happened. Skin doesn't fossilize, hair doesn't leave an impression in the bones. So for decades, the best anyone could say was, sometime after we left the trees. Then, in 2004, Alan Rogers at the University of Utah cracked it through genetics. Rogers and his colleagues published in Current Anthropology, examining the human MC1R gene, the gene responsible for producing melanin, the pigment that protects naked skin from UV radiation. Chimpanzees, covered in fur, carry multiple varied versions of this gene because UV protection doesn't matter much under a coat. But in African human populations, that variation had been wiped out completely. A selective sweep, evolution acting fast and hard, had locked in a single, high-functioning version. The genetic clock in that data pointed to roughly 1.2 million years ago as the outer bound. Humans had been effectively naked at least that long. That date lands almost exactly with the emergence of Homo erectus, a hominin with a modern body, long legs built for distance travel, and fossil evidence of persistence hunting. Dennis Bramble at the University of Utah and Daniel Lieberman at Harvard argued in their landmark 2004 Nature paper that endurance running emerged as a defining trait of the genus Homo around 2 million years ago. The anatomical package, elongated Achilles tendon, nuchal ligament for head stability, broad joint surfaces, narrow waist, appears in the fossil record right alongside the body plan that only makes sense for a creature that sweats to cool down at a run. The hairlessness, the sweat glands, the running body, they arrive together as a suite. So what about the hair that remained? Head hair stayed, armpit hair stayed. If this was all about cooling, why not go entirely bare? Tina Lasisi, an anthropologist who completed her doctoral research at Penn State in 2021 and is now at the University of Michigan, ran an experiment that explains it. Working with thermal engineers at Loughborough University, Lasisi placed human hair wigs of different textures onto a thermal mannequin and exposed them to simulated solar radiation. The results, published in PNAS in 2023, were striking. Tightly coiled hair, the morphology most common among populations with the longest history in equatorial Africa, dramatically reduced solar heat gain at the scalp compared to no hair at all, while simultaneously releasing heat more efficiently than straight hair. The airspace within tightly curled hair insulates from above, keeping intense overhead radiation from overheating the very organ the rest of the naked body was designed to protect. Walking upright is the setup, and scalp hair is the payoff for brain growth. The head stayed hairy because it's a solar panel pointed at the African noon sun. The body lost its fur because the body needed to sweat. Two problems, two solutions. This is the mechanism worth carrying. The great human fur loss wasn't one adaptation, it was a cascade. Bipedalism changed the solar geometry of the body. Heat pressure from an expanding, carotid reed-free brain created urgency. Eccrine sweat glands multiplied across bare skin and became the most powerful cooling system in the primate family. Dark melanin swept in to protect the newly naked skin. And tightly coiled scalp hair stayed, not as a coat, but as a sun shield for the one organ evolution had decided to grow beyond all reason. Someone walking across a heated parking lot in July is living the downstream consequence of all of it. The sweat forming on bare arms. The fact that a human being can, given enough water, literally outrun a horse over a long enough distance. The reason humans can do that ridiculous thing while other great apes sit comfortably in the shade, covered in fur, watching. It started with losing the coat.